Hello, this is my presentation on the effect of different materials on the volume of sound. My question is, what common construction materials can soundproof the best? The inspiration for this project came from when my dad and I both had Zoom meetings at the same time. Mine was a viola lesson, so of course there would be a lot of noise. My mom came to my room and put blankets around my door, saying that it'll help with the soundproofing. But that got me thinking, why wasn't my door and wall good enough to soundproof on their own? And what materials in the door and wall were soundproofing the most? So I started to research. From my background research, I had learned that sound is energy and it moves through waves. Sound reflects or vibrates from one molecule to another to move. Because of this, sound travels faster in denser materials because the molecules are closer together in denser materials. I also learned that the faster sound moves, the quieter it will become, because when sound loses energy, it will become quieter. It's similar to when we run really quickly, we may move faster, but we lose more energy compared to when we walk. I also learned that when sound hits a new material with a large density difference compared to the one that it is currently in, sound will lose a lot of energy, and some sound waves will even reflect off. So from my background research, I created my experiment. My independent variable would be the type of material a soundproofing cube was made of. The materials that I had tested were acoustic panels, insulation foam board, sheetrock, and plywood. My dependent variable would be the volume of a blender motor that the soundproofing cubes would be over. The volume would be measured in decibels. My control would be my blender motor running without a soundproofing cube. My constants would be the distance between the decibel meter and my blender motor, the size of my soundproofing cubes, which was 1 cubic foot, and the materials used in construction that were not part of my independent variable. My hypothesis was that if I use wood as a soundproofing material, then the volume will be reduced the greatest, because wood is the densest material, and my background research said that sound loses more energy in denser materials. So the materials that I had used in this experiment were a decibel meter, a blender motor, a computer with the data analyzing software that would record everything from the decibel meter, and my soundproofing cubes. Each of the soundproofing cubes would be held together with hot glue, E6000 glue, and small nails. Duct tape was used on the edges to prevent any gaps, and Play-Doh was used to fill in any large gaps that the duct tape could not fill. So my procedure for my experiment was that I set up my decibel meter and connected it to the computer. 4 feet away, I put my blender motor, and I put the base of whichever cube I was testing underneath the blender motor. I started recording the data on the computer. I turned on the blender motor, and I put the soundproofing cube on top of the blender motor. The data was recorded for about 10 seconds until the top of the cube was taken off, the blender motor was turned off, and then the data recording was stopped. This was done again for a second trial with the same soundproofing cube, and then 2 trials were done for all of my other materials and my constant. So the results of my experiment were that foam blocks 7% of all sound, the acoustic panels blocked 8%, sheetrock blocked 19%, and wood blocked 21%. This means that plywood, which had soundproofed the best, soundproofed 14% better than insulation foam board, which had soundproofed the least. And from my background research, I learned that 85 decibels and above damage human hearing, and the original sound level of my constant was 90 decibels. but then all of the materials had reduced it below 85 decibels on average. So this is my data table for my experiment. The last column highlighted in red is the percent of sound blocked on average. So my graphs these are my graphs for my experiment. This first graph shows as the meter was recording, what recording the meter got. The meter will record 1 measurement per second. The red line represents wood and the green lines represent sheetrock. And as you can see, they reduced sound far greater than the other two materials. And my second graph shows the highest, lowest, and average decibel recorded for each trial. You can see here too that sheetrock and wood have far lower numbers than the other materials. So in conclusion, my hypothesis was correct. Wood was the best soundproofing material out of all the tested materials. Wood blocked out 21% of all sound, which was 14% better than insulation foam board, which blocked out only 7% of the sound. This also matched my background research, which said that sound loses more energy in denser materials. If someone wanted to use common materials to soundproof their home or build something that was well soundproofed, they can use my research. From this project, I learned how to research efficiently and organize my research. An issue that I had while doing my research was that I was getting very easily confused. I associated sound losing energy with sound moving slower. That didn't make any sense because I knew that when sound travels through denser materials, sound moves faster. Eventually, I realized that when sound moves through denser materials and when sound loses energy, that means that the sound is becoming quieter. Some future ideas for projects that I have after completing this experiment is seeing the effect of air gaps on soundproofing and testing different types of commercial soundproofing materials. I came up with these ideas because a source that I'd read said that air gaps will help soundproofing, but they hadn't specified what type. And if I could compare different commercial soundproofing materials, I could then compare them to the ones that I tested in this project and see if the price is really worth it. So while I was constructing the cubes, there were quite a bit of issues. So the first issue was that, especially on the foam and sheetrock boxes, there were gaps in chunks due to uneven cuts. So this is where the duct tape came in to be put on the edges, and Play-Doh was also used. As you can see in this picture, there are quite a bit of gaps. Probably the biggest issue was that I had not planned for the thickness of the cube when I was planning to cut them. So after I had cut my first cube and put it all together, it made this really wonky shape that did not look like a cube at all. I tried many times with different techniques until I finally figured out one that worked well. And getting a 90-degree angle was slightly difficult, so as you can see in this bottom picture, clamps were used together. Sheetrock also wouldn't adhere to hot glue, as you can see in this first picture. So E6000 glue was used instead, and the clamps were used to hold the pieces together. These are my citations. One of the useful resources from when I was researching was the Soundproofing a Room article from Explain That Stuff. This gave me a basic understanding of sound and how it travels, so that way I could understand my other sources better. Thank you for listening to my presentation. I hope you all have a great day.